40,000 years ago, modern humans carried more Neanderthal DNA in Europe than in Asia. Today, the opposite is true, and geneticists spent decades trying to figure out why. The answer, when it finally came, had nothing to do with where ancient humans met Neanderthals, or how often they interbred. It came down to a wave of farmers who walked out of Africa 10,000 years ago and gradually diluted a genetic inheritance that had been accumulating for tens of thousands of years before them. To understand how this works, you need to go back to the beginning of the story. When modern humans first left Africa and spread into the Middle East and Europe, they encountered Neanderthals and interbred with them. The evidence for this is now well established. Everyone alive today whose ancestry traces back through Eurasia carries somewhere between 1 and 4% Neanderthal DNA in their genome. The interbreeding happened, it was real, and it left a permanent mark on the human species. What puzzled researchers for years was the distribution of that mark. Neanderthals lived primarily in Europe and Western Asia. Their fossils, their tools, their campsites are concentrated there. Eastern Asia has far fewer Neanderthal sites, and none further east than the Altai Mountains in Siberia. Given that geography, you would expect Europeans to carry the most Neanderthal ancestry. Instead, people from East Asia consistently show higher levels of Neanderthal DNA than Europeans do, and nobody could convincingly explain why. A study published in Science Advances finally offered an answer, and it came from analyzing 4,464 ancient and modern human genomes, the oldest of them dating back 40,000 years. When researchers mapped Neanderthal DNA content against geography and time, they found something that reframed the entire question. In the earliest period, 40,000 years ago, the pattern was exactly what you would expect. Humans in Europe carried more Neanderthal ancestry than humans in Asia. The anomaly came later. Something happened in Europe that gradually reduced the Neanderthal signal in the population, and that something was a second wave of migration out of Africa. Around 10,000 years ago, a group of Homo sapiens moved from Africa into the Middle East and became the first Neolithic farmers. These people had left Africa long after Neanderthals had already gone extinct, wiped out by the earlier waves of modern humans. They never interbred with Neanderthals because there were no Neanderthals left to interbreed with. Their genomes were essentially clean of Neanderthal ancestry in any significant amount. When researchers compared the genomes of these early farmers to the hunter-gatherers who were already living in Europe at the time, descendants of the earlier migrations, the difference was striking. The hunter-gatherers carried substantially more Neanderthal DNA. The farmers carried far less. And as the farmers spread across Europe and Western Asia, mixing with the local hunter-gatherer populations along the way, they effectively diluted the Neanderthal ancestry in the resulting population. Generation by generation, the Neanderthal signal in European genomes dropped as the farming ancestry spread. In East Asia, none of this happened. The Neolithic farmers who transformed Europe and Western Asia did not travel east in significant numbers. They stayed broadly within the Middle East and Europe. The people who became East Asia's first farmers were not migrants from Africa's second wave, but descendants of the earlier Homo sapiens who had arrived with high levels of Neanderthal ancestry and never had their genomes diluted by a later incoming population. Their Neanderthal inheritance stayed intact, simply because nobody came along to water it down. This explains the modern pattern cleanly. Europeans have less Neanderthal DNA, not because their ancestors had less contact with Neanderthals, but because a later migration of people with minimal Neanderthal ancestry mixed into the European gene pool and shifted the average downward. East Asians have more because their ancestral population never experienced that dilution event. There is a side question worth addressing because it comes up every time Neanderthal genetics is discussed. Did the Neanderthal genes actually do anything useful? The honest answer is probably not much. at least not in the ways people initially hoped. Early suggestions that Neanderthal ancestry helped modern humans adapt to cold Eurasian climates sounded plausible, but were later contradicted by more detailed analysis. Some specific Neanderthal-derived variants do appear to have functional effects, influencing things like immune response and skin characteristics. But the overall picture from natural selection studies is that Neanderthal genes were largely neutral. They were not strongly favored or strongly eliminated. They just persisted, diluted unevenly across populations by the accidents of migration history. There is one remaining hypothesis that the new research did not fully resolve. Some scientists have suggested that East Asians may have interbred with separate Neanderthal populations in locations we have not yet identified, possibly somewhere in India or Iran. Populations genetically distinct from the European Neanderthals, whose DNA we have sequenced. If that happened, it could also explain why East Asian Neanderthal ancestry looks slightly different in its specific composition from European Neanderthal ancestry. The evidence for this is not conclusive yet. The fossil record and the ancient DNA record from South and Southeast Asia are thin enough that absence of evidence genuinely is not evidence of absence. What the study does establish firmly is that the difference between European and East Asian Neanderthal ancestry levels was not primarily driven by natural selection or by different interbreeding histories in the deep past. It was driven by demographic accident, by who moved where and when, by the fact that a group of farmers walked out of Africa 10,000 years ago, spread across Europe but not across Asia, and in doing so, reshaped the genetic inheritance of half the world, without any awareness that they were doing anything of the kind. The Neanderthal DNA that remains in human genomes today is the residue of encounters that happened between 50 and 40,000 years ago, filtered through every migration and population replacement that followed. The farmers who diluted it in Europe were not trying to erase anything. They were just moving, farming, having children, and living their lives in a landscape that had been shaped by people they knew nothing about and would never know anything about. The genomes of those early farmers, and of the hunter-gatherers they mixed with, and of the Neanderthals whose DNA still circulates in living human cells, are all recoverable now from old bones and ancient sediment. The entire history of who mixed with whom, and when, and what survived, is written in sequences of base pairs that have been sitting in the ground for tens of thousands of years, waiting for someone to learn how to read them.